So today's lecture is just kind of catching up with where we were on 2.7. We ran out of a little bit of time on 2.7. I think I have one extra note if someone wasn't here and didn't have the notes. Want to claim them? One copy. This is actually. If you need a copy of the notes, you can always find that on Blackboard. So just to kind of reiterate, Blackboard is kind of our home base for anything I give you. Anything I give you in class, I'll always try to put an electronic version, a quiz, an exam. I'll try to put an electronic version so later on you can go back and get a blank copy, or you can even get the answer key. I haven't posted the answer key yet for quiz 1, but I'm going to post that today after class, along with the answer key that we take in class today. I'm a quiz 2 in class today. So where we're at, always nice to kind of see where we're at and where we're going. And I want to test to sneak up on you guys. So today we're going to cover 2.7, the rest of 2.7. I have like 5 minutes of lecture left, and then I want to pull up Alex and show you guys just kind of the interface of the written homework on Alex. And then I'm going to give you a quiz that summarized 2.3, 2.6, and 2.7. So the more exposure you can get to this kind of stuff, that's better come the test a week from Friday, right? So Friday we'll go over 2.8 for the first time. We'll hit it again on Monday. The review on Wednesday. So I'll probably even kind of have a mini pre-exam for you, so you can probably to start the class, give you guys the exam, give you guys 30 minutes to work on it by yourself, and then the last 20 minutes say, what did you struggle with and why? And then hopefully you can weed out what you need to study, what you need to look up on, and then the test will be Friday. We were on 2.7 last time. We were talking about increasing, decreasing, and constant functions. Generally, this doesn't cause a problem except for notation. You want to make sure you're writing the intervals correct in interval notation. On Alex, they'll say, is the function increasing, decreasing, or constant from A to B? So this might be A, this might be B. And you're picking increasing, decreasing, or constant. And then B to C, C to D, D to E. Did it? Yeah. Are you talking about the pie in your Alex or your homework Alex? The pie, yeah. So the pie is, they try to say, if you did well on your pretest, then they'll say, oh, maybe you don't have to go through these 5 objectives. You already know them. So they might say, okay, you might know objective 1, 2, and 3. So they do kind of jump you throughout it. And I'll pull up the pie and just kind of give you guys some feedback of how to read it, because sometimes students aren't too sure how far along in the pie they are. And you get your points based on the objective. So if there's 20 objectives and you get 10 of them, you have 50% of your pie. So by the time, going back to the syllabus here, by 2/5 at 11:59 p.m., Alex takes a screenshot or a snapshot of where you're at, and then we'll put that grade in the grade book. So currently your grade can possibly change because you can always go back in homework unlimited times and do it for more attempts. So hopefully you get 100% on every homework assignment. But it won't actually post that for the gradebook for me to download until they're due. And they're due the day before the test at 11:59 p.m. Then once it gets interesting, because if you don't meet all the objectives in the first pie slice, they might come up in the second pie slice because they might be a prereq for another objective. So you might be doing objectives in the first pie and not getting credit for them later in the semester. So ideally, you want to get all the way through your pie and get 100% on all your homeworks, and that's your Alex grade. I'm also putting in the in-class quizzes we do in Alex as well as external assignments. And I'll drop the lowest couple of those as we go. I just want to have some connections there with you guys. We didn't get to this one last time. The interval notation where the function is increasing. So even though this has a closed dot, I'm going to write open interval. I think Alex even says write an open interval in which the function is increasing. So again, we look at the x-axis. So from -5 to -3, I'm increasing. Union from -1 to 2, I'm increasing. You guys see that? And this comes up later on in math. An increasing function, that's a positive slope. A decreasing function is a negative slope, and a constant function is a zero slope. So we look at, problems that might look like this. We might want to find this point as a maximum, and we can actually use calculus to do that because we know the slope on this side is positive and the slope on this side is negative. So the slope here has to be 0, and I can solve for that. But again, you might be thinking, why am I, this is elementary. It has more purpose later on, so we want to build a good foundation. Decreasing function is decreasing from 2 to infinity. Constant, from -3 to -1. Any questions on that? Like, yes, this is not that difficult. Determine the relative minimum and maximum of a function. This is kind of where notation comes in. That's important. It'll ask you, where does the minimum or maximum occur? What is the minimum or the maximum? So here, A, this is the point in which the maximum occurs. Let's see if I use the same notation your book uses. They say happen. So A is where the relative maximum of the function happens. You could also think of occurs. F of A is the maximum, relative maximum. So this will come in handy when we talk about application problems. If I say A is the value that I sell the t-shirt at, so the price of the t-shirt, this is a revenue function. So if I price my t-shirt too much, I'm not going to sell as much, so I'm not going to make as much revenue. If I price it too little, I might sell a lot, but I'm not making very much profit off each t-shirt. So this might be a revenue function, and I want to talk about maximizing my profits, so maximizing my revenue. So this A value would be the value at which I sell the t-shirt to maximize my profit. The F of A, when I plug that into my profit function or my revenue function, that's going to tell me what my profit would be at that value. So a little bit with notation, A is where the maximum occurs, but F of A is the maximum value. Does that make sense? And we'll do it on the quiz today. We're going to do that. And you're going to be able to see if it says, where does a minimum occur? You're going to use the X points. What are the minimums? You use the corresponding Y points to that.
So you said F of A is the what?
F of A, so if I plug A into the function, that is the relative maximum value. That might be the maximum, that might be my revenue. I might be getting, $5, $10, $15, $5, $10, $15. So I might want to say, what do I need to price my t-shirt at to get maximum value, to get maximum profit? A would be the price of the t-shirt. F of A would be the maximum.
So A is where the maximum occurs.
Good.
The F of A
is the maximum value. Yes. Question.
Well, as another different way of thinking to help it, like the maximum population or something as to a specific country or something that would have the most, A would be China or something like that.
You could think of the plots, yeah, if you're going to say the X value and the Y value. If I ask who has the maximum population, the answer would be A. If I say what is the maximum population, it would be the value of people that live in China, or the number of people that live in China. Yeah. So it's kind of important to idea this. Really later on, it has a lot more weight to it. So in calculus, it's all about finding these points. In college algebra, we just have to know they exist and be able to identify them as x comma f of a, or a comma f of a, or x comma f of x. So pulling up Alex, there's a little disconnect again. I say there's a little disconnect from doing Alex problem and then when you get a written problem. So as I'm pulling that out, I'm going to go ahead and pass out your guys' little in-class quiz today. So again, these are meant to be assisted. It's not like you're on your own here. That's what the test is for. The test is close notes, close books, close neighbors, and really get it. This is for you to kind of practice to get ready for the test. And I'll collect it and I'll give you feedback and I'll give you points for doing that. So hopefully it's a win-win. Simon Chico around?
Yeah, I know that.
I'm not very.
Oh, you know how to.
Yeah, I think
Sorry.
I did more on top of passing that around. See if I can pull up the student's view without showing anything. Students, ooh, thank you. Occasionally I'll even take screenshots from Alex and post them on like an in-class thing. This example in the back, that's a screenshot from Alex. It didn't print the best. I apologize in that. I will make sure when you get to the exam, it's not just a screenshot, but for a quiz, I figured it'd save me a little bit of time. Just to kind of review the pie here, every time you go into, it'll tell you how many objectives you've met for that section. So there's 42 in this section, and I've only done 2 of them. So I need to be working more in the pie, and I can click on, possible ones to work on. And then you want to get so many right in a row, and it'll tell you that you learned that objective. And then next time you go in, 3 out of 42 and so forth. You can't go into the pie if you have an open assignment, so you have to be a little careful of that. You have unlimited attempts, but you can only get into the ones for chapter 2. So 2.7. Start the homework. Some of this shows up from 2.7, like this example. Very similar to the one here. So I don't think there's a lot of disconnect from being able to evaluate this function. And you can see that there's 5 problems in this homework assignment. You can go through them, skip around. If you don't want to enter one yet, you can go to the next question, and you should be able to go back to 1. This is the example I was talking about, increasing, decreasing, and constant. So from A to B, is it increasing, decreasing, or constant? Where I wouldn't ask you that probably on a test, I would say write the intervals in which the function is decreasing. Which would be the example here where you actually have to put it in interval notation. And here's the point where I was saying it says strictly decreasing. That means open interval. Strictly increasing, strictly decreasing, or strictly constant, you would input an open interval here. And you might have to use the notation here. If it's going to be a union, you have to click that first. and then you have to click the right form. Is it open interval, close interval, and get the right form, and then you put in your answers. So you can't just use a parenthesis or a comma. You have to put the right form and then enter the numbers. And I'm not saying this one's a union, but if it was, you would have to use that there. So if you guys want to take some time to work on the in-class quiz number 2, we'll kind of be walking around and giving you guys some feedback. Be careful on number 1. Actually, I didn't mean number 1, but on number 1B, both conditions have to be satisfied for it to be in the domain. Okay? The denominator cannot equal 0, and the numerator has to equal 0 or be greater than that. You can't take a square root of a negative number, and you can't divide by 0.
I don't know any of you, so can I get out my book?
Yeah, definitely. This is not the test, right? This is a learning process. The thing what I don't want to happen is I give you the test and you say I've never seen this before, I don't know what to do. So yeah, and you can talk to your neighbor, and I'm gonna go around and give you guys support too. I just feel like you guys need this exposure before the exam.
Yeah, if this is gonna be on there, definitely.
Yeah. Good. I can go. Oh, no, that's all right, sorry. That's right. Here's the only thing I have an issue with. If it's x equals -1, but everything else. -1, x is -1, y is +2. Well, it would be 1 if x is less than -1. So you'd have an open circle here, and you'd go this way, because x is less than -1. This would just be a dot. And then this would be an open interval, right? If x is greater than -1, it goes 3. Which is open that way. If it equals -1, then it's a closed dot. It doesn't go anywhere, it's only at one point. At 1, the value is 152. But everything to the left is 1, and everything to the right is 3.
Okay, I don't know what to do with this.
Okay, for domain, you have to say, do you have any issues? I cannot plug in a negative number, right? So I can't plug in the square root of a negative number. So I want to make sure my denominator is negative. It's also in the denominator, so it can't be 0. You can take a square root of 0, that's fine, but you can't if it's in the denominator.
Yeah.
So you want to make sure that x plus 6 has to always be greater than 0.
Okay. I know all that. I just don't know how to
How to
set it
write
up.
it, right?
Yeah, because I haven't done one like this. So do I just use this? Let's see, it has to be, it cannot be less than, is that right?
Well, it can't be less than, so you want it to be greater than.
Oh, so it's one, okay, so there's this other one.
Greater than 0.
Oh, okay, so you can see, or equal?
If it was in the numerator, it could be equal, but it's in the
Oh,
denominator.
so it can't be 0, okay, so it's just that, okay.
And then you want to put 0, and then
Over
solve
here.
for x, yeah. You solve for x, and then write it in interval notation.
Oh, okay,
So where on the number line is that?
X, equals.
Greater than, you still want it greater than, yeah. Greater, so x has to be greater than -6.
Oh, right, okay.
It can't be -6, because that would be 0.
Okay.
But it has to be bigger than -6. You're getting there. So in interval notation, I would write open parenthesis -6, comma, infinity, close parenthesis.
Okay.
So it's everything greater than -6. But if I put in -6, I have a problem.
Bracket.
No, you always use open parentheses with infinity.
So,
Bracket means it can equal that.
so it has, so it can So, well, this one would be a bracket then, wouldn't it?
No, it wouldn't be because it has to be strictly greater than. Because if it's equal to -6, I have a 0.
Oh, right, okay.
If it was in the numerator, you'd be bracket, it'd be a bracket. Because it could be -6. And here we have two things going on, so you have to see where they overlap. Or, yeah, you basically have to find a numerator and take out any problems that are in the denominator. And I'll go over kind of the notation on it in a little bit. Close. Yeah, so, good. You know, have to be greater than -8, but it can't be. That's right. You know it cannot equal that.
Okay.
So really, we could write
Then that,
minus
this
8,
needs to be, okay.
yeah, minus, it would be union minus 8 over 3. So you're pretty close. But you want to basically, from -8 to -8 over 3, all of that, you don't include 8 over 3, union 8 over 3, you don't include it, all of that.
Oh, okay.
So you had the right idea, it was just.
The way okay.
And so you see that?
Mhm.
That's okay.
Yes.
Okay, good.
Oh, no, I see what you're saying.
Good. Okay. If you want to take it and then turn it into me on.
All that matters, all that
Let
matters.
me go ahead and say we're gonna go on through. Take it and just turn it into next turn. Okay, that's fine. I mean, eventually, if they have. We have a little bit of this. Come out good for you guys? You can write it as a mixed number or a fraction on number 2 for f of -5. The fraction is perfectly fine. Close here. You got the kind of the right concept. You can be -8, so it would be a bracket. Okay, but you want to take out, this is here. This is actually saying x cannot equal this, right? See, it doesn't, it's not greater than or less than, it just can't equal it. And then here, this is greater than or equal to -8. So if I was to write it, I'd start with -8. Then I go to -8 over 3. Open that, because it can't equal that. Union -8 over 3 to infinity. Then it would be your answer there. Okay, so you're kind of close to the way you write it here, except this is really going to be -8 over 3. That would be the correct answer.
Okay, thank you.
That all looks good except these two are issues. Here, just a little scary the way you wrote this, and that's something I'm going to talk about. It has local minimum at -2 and at 3, but the way you wrote this looks like the point -2, comma 3. Yeah, so it wouldn't be set notation, and the local minimum value would be -3 and 0, which is a little scary the way you wrote that. I just get rid of them altogether. And maybe even say x is -2 and x is 3, and then the minimum values are -3 and 0. But do you see how this looks like a point? And it's mostly just kind of being a little, tentative about it, but I think it's important to understand what it's going along. Yeah. That, I believe that's right. I have the answer there, but I just, those two aren't. Yeah. So go ahead and give me more right out here.
So.
If I put in -5.5, that's fine. If I put in -5.5, -5.5 plus 6.5, which is the square root of 2. No, because -5.5 is on the left side of it. I think you're along the line that it's not, it can't be -6, so you want to put -6 open parentheses to infinity. Well, I think you got the kind of the concept of the numerator, right? X has to be greater than -8. And it can't be 0. So you have to find that point. Yeah. Minus So it's a combination of things. In a minute, I'm gonna write it, some of it on the left. So here it's saying, at what value does the function have a minimum? So what x values give me a minimum, a relative minimum, or a local minimum? Good.
3.
And -2. Okay, -2, it'll give you a local minimum. And x equals 3. So 3 would be 1 and -2. And then what are the local minimum values?
0.
Yep. Yep, you're good there.
So, all five
So what are the values in which the function outputs a minimum value for that region? You write the x value that corresponds to that point. So you'll have two x values and you'll have two y values. So 3 and -2 are local minimum values. Or 3 and local minimum occurs at 3 and -2. What are the local minimum values at those corresponding points? Okay, yeah, so you said -2, 3. So the local minimum value at 3 is 0. So the local minimum value would be 0 and -3. Right. It's just a little bit inattentive, right, of like what I'm trying to get across here, but it's important to think of a local minimum occurs at what input value. That's what this first line is saying. Where does the local minimum occur? At what values the function have a local minimum? The values are at -2 and 3. If I plug that into my function, it's going to give me a local minimum.
Gotcha.
Here, all local minimum values of the function. What are the local minimum values? Well, the local minimum values are -3 and 0. Okay?
Yeah, that makes sense.
So you just be careful that you don't write it at that point. Don't put parentheses on it, 'cause that would lose the local connection. You could, if it asks for, a local minimum. Yeah, so, yeah, this is basically saying, this is saying 3, 0, and this is saying -2, -3. But you wanna make sure that you understand the 3 is the input and the 0 is the output. -2 is the input and the -3 is the output. So one of them, yeah, the y is your output, it's your range. The x is the domain. Good. So it's not greater than, it cannot equal 0. So this would be, yeah, because it's in the denominator. It doesn't have a square root under it, so we're perfectly fine. As long as, yeah, you're fine as long as 8 plus 3x doesn't equal 0. Yes. So it can't equal 0. So here you would say x cannot equal -8/3. And then you have to worry about the numerator. That is when 8 plus x has to be greater than or equal to 0. Yes. So x has to be greater than or equal to -8. So then you go from -8 to -8/3, union -8/3 divided. So you got half of it here. The other half is from -8 to -8/3.
That's the only time you do that is when there's the square root on top.
You would do it if it was in the denominator as well, but you would get rid of the equals to 0, because the denominator can't equal 0. Right? Yeah, so here it's just two things are going on. Here only one thing is The denominator has to be strictly greater than 0. So you got that. Here, the numerator has to be greater or equal to 0, but the denominator can't be 0. So in that interval, minus 8 over 3 would give you a problem in the denominator. So you have to go to minus 8 over 3, union minus 8 over 3 to infinity. Here you include minus 8 though. You'd have a bracket there. Here, this looks good, so it'd be minus 1 over 4. Oh. So you can plug it in your calculator. Minus 1/4 times 25. It wouldn't be minus 5, it would be times 25, right? Times 25 and then plus 5. You could plug the minus 5 and then square it. If you want to put the first, you could plug in the minus 5 and square it. If you want to put it in parentheses, and then good, and then add 5 to that. And that's your answer. Minus 1 and 1/4. You also have this ABC button. And if you click on that, you can do it that way. So this is also minus 5 over 4. It's the same thing. Minus 5 over 4, and this answer is the same. So yeah, you're correct in plugging it in that one. Okay, so we're close. Here, let's see your pencil. Just write something here. So this is just in the denominator. There's no square root here. So this is gonna have a problem when it equals 0.
Or did you just do this problem again?
Yeah,
I was looking
we only
at
have a
this
problem
one,
when it
there's three.
equals 0. So we want x cannot equal minus 8 over 3. Halfway. Yeah. So then you have to worry about the numerator. Because I can't take a square root of a negative number and give me a problem. So I have to then make sure that this is greater than or equal.
That's not a fraction.
Yeah, just with the numerator. So here x is going to be greater than or equal to minus 8. Right? So then I'm going to say
Like my last teacher.
minus 8 minus 8 over 3, right? Because that's when I have a problem. Union minus 8 over 3 to infinity. So there's a little disconnect. It takes a while to kind of get used to.
Nobody asked questions.
Yes, yes. You had about half of it.
Like she's starting off like so slow. Because I'm too bad at math.
So if I was to draw a number line here,
This is very nice.
I know for the numerator, I have to be greater than minus 8. So all this is kind of shaded, right? This would be minus 8 to infinity. Then I say, where do else do I have a problem? I have a problem here at minus 8 over 3, that's on this side. So I have to say this region, because I have to break it up anytime I have a problem. If it was over here, like minus 10 was a problem, I wouldn't even worry about it, because it's not even in my interval. If there's any problem in your interval, you're gonna have to use a union. So for minus 8, no problems, no problems. Oh, I have a problem at minus 8 over 3, so I have to break that into one interval. And then for minus 8 over 3, all the way to infinity down, I don't have a problem, so I can write it this way. And you always write the smallest number first, and then the larger number on the right-hand side. Does that make sense there? That's good, except it cannot equal minus 6, so you have to have it open. Right, so you, yes, they're both open. Because if it equals minus 6, it's 0 in the denominator, and that's the problem. If it was this, you had the right answer for just this problem, for the square root of x plus 6. You had the right answer, but we had 1 over the square root of x plus 6, which is in the denominator, so it cannot equal 0. Does that make sense? Okay.
Okay, just wondering, so like, looking at the notes, like there's 3, and then here there's just 2. Do I just do one of them twice? And
Well,
then
yeah,
the
this is
last one
saying-
with 3?
Kind of, this is saying that these are possible things you could input. You can put anything but -2 in this function. As long as it's not -2, you're gonna plug it in this function. If it's -2, it's always gonna be 3.
Okay, so
Here, we're saying from -4 to -1, to -1 to 2, and then greater than 2.
if I put the -2 with this one, because this is x equals -2, I just put 3 right here.
Yes, it's always 3 when x equals -2.
Okay,
That's what it's saying. And then the 0, is 0 -2? No, so I'm not here. It's saying anything that's not -2.
yeah,
So I plug 0 in this function. I get my output there.
okay, makes sense.
See, that's one thing I didn't know.
Yeah, so that's what the -2 is saying. If the x is -2, you take it as a, so you're okay. If it was something like x, then the answer would be -2. If it was x squared, your answer would be 4. You plug in, yeah, does that help? Kind of connect? You're looking at your algebra.
Oh my God, I'm so confused on this.
Here, this is good. So let me just finish this. You have -1/4
I shouldn't have.
times 25 plus 5. You may not do that, you can write it different ways. So here, if I should write this as -25 over 4, and then if I'm adding fraction, I need a common denominator, so I could multiply top and bottom by 4. So really this would be 20 over 4. Which is -5 over 4, which is -1.25.
Oh.
Yeah, if you take 5 minus 6.25, your answer. Yeah, so
That's why.
So you weren't wrong, except just where that negative came in. And this is just fractions, which people are like, eh. So you could have plugged it in your calculator, you should have been able to compare and say, -1/4, right? Times, open parentheses, -5 squared, enter, plus 5. That should be that. Let's go back and do it. I think it's the negative. -1/4. That's I didn't say -1/4. -1/4. Times.
Do you understand?
-5.
I don't know.
I know, that's what I mean, it says that the function we use to
Getting
find the
comfortable with your
optimum number,
calculator.
so do we just plug in whatever?
If you're comfortable with that. What you have there is perfectly fine. And that's the point I'm trying to,
Or less than, I don't.
in this problem, is I'm testing. I'm testing to understand what the -5 plugging in this function means. It means plugging in this one. The -2, you're plugging in this one. 0, you're plugging in this one. But sometimes the application gets in the way of being able to test that. You can evaluate it. Like say I understand plugging in, but you're doing that wrong. So that's bad for that.
I've been waiting, like, to do the Alex thing for what we're doing in class. You know, like, when we went over 2.6, then I did the 2.6 Alex, because I'm really kind of lost this period in this, I struggle with math. So,
With graphing?
I have no idea what this is asking me, I don't.
So just like here, this piece by function is saying, the function is this as long as it's not -2. Here, it's saying constant 1, 2, or 3. So this is output. If I plug in something less than -1, always less than -1, I'm gonna output 1. 1, 1, 1, 1, 1, 1.
I
It's
mean,
strictly
you're not
less than, so I can just
scheduled,
open
however,
it.
like, they're.
So all I
it's
do
only
is,
10 minute walk,
okay,
maybe
so
go
right
get
here, I
like
just
a
put
car,
the.
Open it like that, and then all the way to
You just
the
have to
left
walk
of that
outside.
would always be
It's
1.
really convenient to walk.
Okay.
So you're graphing this idea as saying, if I'm less than -1, I'm always 1.
Okay.
So if I said, what is g of -5? Well, g of -5 is 1. G of -4 is 1. G of -2 is 1, because the value of my input is less than 1, so that's telling me I'm less than 1.
That would just be, okay.
At
So
2,
for 2, I'm gonna.
or sorry, no, x equals -1. X equals -1, I'm outputting 2. So when I plug in -1, I output 2, and it equals what you say.
Like they well.
Close.
I output 2.
You just have to like do it right
So
away.
I use a closed circle, but it's still.
But it's not going anywhere, because it only happens at -1.
Okay. Okay. And then that one is x is greater than. minus one, so it'd be in
Like, I was
opposite
in the
direction.
I told her I was gonna be
It
in
would be
Florida,
to
so
the
I, like,
right.
scheduled to take a test, like, late.
So I'm always three
And then
times
my
greater
flight
than
got
minus
delayed,
one.
and like, I had to be back, and I wasn't safe to it, so we flew. I got home at like 2:30 in the morning, she wanted me to be there at 8 in the morning. I just didn't care.
Wait, I'm not even, okay, I'm not even on the right thing. I'm like,
That's hard.
I
Your- your
like,
notation
just
here
show her that
is
we're
good.
there was nice.
So.
Like I did, you go to negative one and then like,
So
it's
this
one,
is actually.
you go up one.
so I get my.
This makes it open.
But it's sort of like where it's like,
That's why I'm confused, like, that should be.
I feel like I'm overanalyzing. So you already have a four here.
Right.
If I multiply
With some of the
by
teachers,
four,
like,
I really have minus 25 plus 20.
Maybe I would understand.
Right.
If I understood it, I don't know, I
So
think,
if I do that, minus like.
what I don't understand is, like, the f of x should be, okay, the g of x, is y, like, in general, that's y, so if y equals 3, then I'll put my little thing right here where 3 is for y, but it has to be x, the x value, the whole x value has to be greater than -1, so I can only go that way.
Makes sense.
I have to go the opposite of -1. So I just asking. Does that kind of make sense? I'm like so lost.
Yeah, I look at it and then I make it more complicated than it's
Yeah.
supposed to.
So
So if you average the graph, I would have been
I just think that's starting at.
comma. What?
Yeah, that would be. Like here, it's kind of going to graph.
Right, and you know, you can start
So can you
that,
guys
like I got
explain
that.
this one to me? I get, I thought that x couldn't be greater than negative. Is it greater than negative?
But like
I
whenever
know
you.
it can't be -3 right here because,
I just don't want to get dirty. Right, well, like, put nice clothes on and you.
but I don't understand how people are, I just don't like.
Explain to me.
So like on the top one, like you're just trying to get it to where like greater than or equal to 0, so you put 8 plus equal to 0, then you minus 8, so then you have like x -8. So that's where the -8 comes from. And then on the bottom right here, you've got 8 plus 0. You minus the 8 over here, and then you divide by 3, and then that's where the -8 over 3 comes. Now, if someone like formatted it to be like this, you go ahead and copy it. But I don't understand like the unit stuff. Like I don't understand. Or like infinities, which are like close bracket, -8, 8 over 3,
Close bracket -8.
and then it's the curve run after the.
But you're right, but the parentheses make instance a little bit of cleanup, because you think, oh, that's.
I don't know, like I understand like how to figure out like points, but I don't understand whenever you have to start throwing the infinities.
Yes, that's good. You don't go out.
So I don't know, it was,
And then like, hey, there's no time.
I mean.
Because
I
that's
think
almost
every
the
now and
same
then-
impact. I mean, that is the same.
So, yeah, here,
This just
without,
looks like.
really what you're saying here is
Oh,
x plus 6 needs to be
I
greater
don't know.
than.
Sorry, let me try.
Here, this needs to just be greater than or equal.
Unless you're like.
But this can't, so you're right here, but you need to do that on top of n plus 8 plus x greater than or equal.
I chose a degree in business.
What they have in common. Here, you want to say when it's n plus 6 greater than or equal.
Blah, 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 everyone has.
And then solve, and then write that in interval notation with your parentheses.
Oh,
I think since you have to like figure out 2 x's instead of 1 x over here, that's what it is.
Yeah, you can't choose first. please, excuse. That is right.
That I got my GED, so I have.
Please, excuse me, you're in college. Parentheses.
Why am I here? I have my GED, I don't have to.
Then you do all your exponents.
Yeah.
Which shows that
I
I-
still
Then
have,
you do
yeah.
multiplication. So the exponent is here, then multiplication. Exponents become multiplication.
I want to see the.
So I didn't want to do it that way, but.
It's a teamwork, right?
Like, I didn't even.
Where was it?
The lines go this way.
That's literally what.
So what this is saying, one, this is the one value. If x is less than minus one. This would go
They are,
to this point here. Technically, these are open because it doesn't say equal. So it's open here, and closed here. If it doesn't equal. So yeah, here, this is just strictly less than, that means open. If it's less than or equal to, that means close. Or equal. Equal is close. Just that. All right, so we have 2 minutes, and I don't really have time to go over it, but hopefully I was able to answer questions. Yeah, if you want to turn it in before you leave, yeah, and then I'll look that over and give it back to you guys in class next time. Here, just highlight here.
So are each